That's an important question. So what I want to say is that the overall carbon footprint of THP plus AD is clearly positive. THP increase renewable biogas production, improves energy recovery, and reduce reliance of fossil fuels. So as I have shown in the presentation, the process delivers significant gains in methane production and overall energy efficiency. So concerning especially the methane emissions, CAMBI THP system are designed as fully gas-tight installation. So the process operates in sealed equipment under controlled industrial conditions, so it doesn't create any risk of fugitive methane emissions. So this is an important difference between if we compare it to some conventional sludge handling process, where uncontrolled methane losses are occurring, of course. So THP also improves the sludge developability and volatile solid destruction, which reduce the amount of sludge that needs to be transported, dried, or disposed. So this further lowers the overall carbon footprint and the sludge treatment line. So if I combine higher renewable energy production, lower external energy demand, reduce volumes of sludge, and fully gas-tight THP equipment, the result is a significantly proven overall environmental balance without any doubt. So if I understand correctly the question is about the operability of the digestion combined with THP. So what I want to tell you is, according to the return of experience of operators, we need first to manage properly the commissioning of the plant and the ramp up of the reactor. Because, of course, we generate much more available COD than a usual reactor, which means that we increase the organic loading rate of the reactor, which is unusual. But it doesn't mean that the reactor is working bad. The reactor is working very well because it has a lot of food. So we are achieving a very higher organic loading rate in an anaerobic digester, even if it is a mesophilic or a thermophilic reactor. We decrease the risk, we clearly decrease the risk when it is stabilized, when we clearly decrease the risk of foaming. Why? It is just because we decrease the viscosity of the sludge. As far as we solubilize the sludge, we have less viscosity, and if we have less viscosity, we have less risk of foaming. So you have to understand, and it's very important because this is a direct return of experience of our operators, the digester combined with a THP is much more stable than a digester that has just a biological enhancement. Because, as I told you previously, biology remains biology, and when you want to enhance a reactor, for example, you can just take the example of a simple thermophilic solution. It is very well known in the market that thermophilic is a little more performant, but much more fragile than mesophilic. Fragile because you have less variability and less diversity of methanogens, though less bacteria to manage it properly and to adapt to the situation, and because of the higher temperature within the reactor, not before like us, but within the reactor, then you create unstable biochemical condition, and then you have a lot of foaming risk in a thermophilic reactor or a combined thermophilic like TPAD and these kind of things. So my answer to you is, according to our operators on the field, it is much more stable to operate a THP plus ID than a usual system. Most of the time, the viscosity of the sludge, that is the big issue for dewatering, the viscosity of the sludge is linked to the presence of exopolymer. So exopolymers are molecules with a characteristic of big viscous characteristics. So when we treat by THP this sludge, we just destroy this kind of components. And this just liberates the COD that was inside this exopolymer in more soluble COD and decrease the waterability of the system. So it's really a pure physical effect.